I would like us to talk about how do we troubleshoot this IP version 4 and 6 static routes. And so what I'm going to do is that I will take us through a very brief about troubleshooting. This is very brief, and then we can do one activity, one tough activity, and then we just call it a day. And so for troubleshooting, basically, I want you guys to know just one thing, that all that we have been learning is all about troubleshooting. Okay, if you cannot troubleshoot a network, you have no business being in that network, because employers are looking for good troubleshooter, people with good troubleshooting skills. And anyone who doesn't have that is gonna be having a problem. And so we're going to explain how a router processes packets when a static route is configured, and then we'll troubleshoot some common static and default route configuration issues. And so the first thing that I want us to talk about is I want us to look at what happens really when a router receives a packet, for example, R1 here. So if PC1 sends a packet, wants to send a packet to PC3, PC3 is on LAN, so right here. So PC1 here wants to send a packet all the way, okay, to PC3. That means that packet will have to go from PC1 to R2. R2 is going to send it to R1 is going to send it to R2. R2 will send it to R3, and R3 is going to send it to PC3 right here. Okay. And so what is going to happen is this, that if PC1 addresses that packet to PC3 and send it to the default gateway address, which is for R1, and when the packet arrives on, the G00 interface of R1, R1 must do the process we learned in the module 1. Remember encapsulation and de-encapsulation? So the packet arrives there, and PC router R1 has to de-encapsulate that packet to be able to look at the destination IP address of the packet. Okay. Now, once the router has determined the destination IP address, if that IP address matches a static route entry on R1, so R1 will use that route to identify the next hop IP address or the exit interface. All right. So the router receives a packet, de-encapsulates it to see the destination IP, and then if the IP matches one of the routes or one of the routes within the routing table, static routes, then because each route in the routing table must either have a next hop IP or an exit interface, or both of them. So then the router is going to use the exit interface or the next hop to forward that packet. In case the IP address does not match a specific route within the destination routes within the routing table, then what happens is that if R1 has a default route configured, a default route is like a universal route, R1 is going to use the default route to forward that packet to the next hop router. What if there's no default route? So that means the IP address does not match any route in the routing table. Then R1 is going to drop that packet and send an ICMP message back to the source of the device. So back to PC1. And that is something that happens all over and over again. So the routing table has a very significant role for the router to process any packets. All right. Now, it is important to note that, if R1 matches a routing table entry, obviously it will have to re-encapsulate that packet with a new frame. That means with a new MAC address, and it will forward it out to the interface serial right here. It will have to forward it through the exit interface, which is serial 0/1/0. Okay. Now, R2 will receive that packet, okay, on its interface S010. And if it receives it, the packet goes through the same test. All right. Like we said, it will have to de-encapsulate the packet in order to see the destination IP. Okay. Just like R1 did. So if R2 finds a match in the routing table, then it's going to use one of its exit interfaces or next hop to forward that packet to the next device. Okay. In our example, if it finds a match, then obviously it's going to send it through the exit interface S011 or the next swap of R3, which is 192.168.1.1. Okay. If there's no match in the routing table and R3 has a default route, then R2 has a default route, then R2 will go use the default route for that packet. And if it does not have a default route, then that packet will be dropped. R2 will have to send an ICMP message to R1 that it did actually get the honor, and that packet will be dropped. Okay. And that's how it will move until it gets to PC3, until it gets to the PC3. Now, like I said, R3 will also receive the packet, de-encapsulate it, and search its routing table. If the destination IP address matches the directly connected network, that is G00 going to R3, the R3 must search its ARP table and look for the MAC address of PC3, all right? And then forward it through that. If there's no ARP exit entry on R3, then R3 must send what's called an ARP request or ARP request, which will be sent through that interface G00 to go to PC3. This is the working of ARP. Then ARP, of course, will respond with an ARP reply telling R3 that I am the owner of that IP address and this is my MAC address. Until R3 must store the MAC address of PC3 so that R3 can now forward that packet to PC3 since R3 is on the same network with PC3 as its default gateway. So that is what they're basically trying to explain here. Now, a few features that I want you guys to note here, and this happens with the network changes. Wherever a network fails, okay, and that can happen because of either an interface has failed or the service provider has dropped some connection. Like, if it's fiber optic, someone can cut the fiber optic cable, or, the link can become unsaturated due to, a bottleneck or, just due to, a lower speed port receiving traffic from a higher speed port, and that can cause that oversaturation. You, the network administrator, is fully responsible for trying to troubleshoot. That means you must look for the problem and you must provide a solution to it. Now, to efficiently find and solve these issues, it is advantageous to be very familiar. You, as the network administrator, please try to be familiar with tools that help isolate some of these problems as quick as possible, because your boss needs the solution as much as possible, because any minute lost is money lost. And the last time I checked, no boss wants money to be lost. And so some of the most important tools for you guys is ping, very, very important for testing end-to-end connectivity. Traceroute is the sister of ping, all these ICMP protocols. We have been using show IP route to view the routing table content. Check IP address configurations on interfaces, show IP interface brief, and check some, use show CDP neighbors to discover, directly connected Cisco devices. And of course, there's show LLDP neighbors to discover, other vendor network devices. And so these are very important tools that we use for troubleshooting, and you should pay so much attention to them. Now, it is important to note that problems like this will always happen, and you, the network administrator, needs to be very keen. You need to be very, very keen, because it's only through keenness that you will be able to identify some of these problems that we find in our network. For example, we are doing an extended ping from R1 G00. You see R1 G00 interface to PC3, and it fails. And so we cannot be able to ping from R1 G00 to PC3, but pings from R1 S00. So let me just show you that. So from here, we cannot ping R3, but R1 can ping R2, and R2 can ping R3. Very interesting. So by doing that, we now have realized that the problem is not anywhere between R1 to R2 to R3. The problem is actually between R3, to PC3. Now, So what happens is that we need to have something between R1. R1 is not actually, when you view the routing table, we realize that R2 is not reaching the network where the LAN is. And most probably, the problem must have been, if you look at the static route configured here in R2, 172.16.3.0, look at it this way. So in R2, we say 192.160.2.3.0. Okay. And let me see, 172.16.3.0 on R2. R2 is not having this network here. R2 is not having this network. And so what we need to do is we need to be able to add this network. Since we could not ping from here, but we could be able to ping from here, it means this network needs to be added in R2. And let's see how it was added. If you're adding network 172 16.3.0, which is the network here, we add it in R2. What is our next hop? The next hop is supposed to be 172.16.2.1. Look at the next hop that was given here, .1.1. So this is where the mistake is. And we therefore need to correct that. And so what's going to happen? We need to remove this route and we need to configure a good route and we need to say that is IP route 172.16.3.0, put the subnet mask, and we need to put the correct next hop, this one and not this one. Okay, we need to say 172.16.2.1 and not 192.168.1.1. So that was a small problem that was here that we have actually been able to solve. But anyway, I want us to reason together. I want us to reason together to be able to work out something that I will also give you to work out on. Now, looking at this diagram here, looking at this diagram over here, you realize that we have a very serious topology here. A router called edge router connected to LAN 1, LAN 2. The edge router is still connected to ISP 1, ISP 2, and ISP has a connection here, which is connected to a customer server right here. And so this network is going to be configured with static routes here. And I want us to pay attention and just be able to see how can we make sense of this network. Now, we are going to configure the following. You're going to configure IPv4, static and floating, static default routes. We'll configure IPv6, static and floating, static default routes. IPv4, static and floating, static default routes to internal LANs. And IPv6, static and floating, static routes to the internal LANs. Then we'll configure IPv4 host routes and we configure IPv6 host static routes. You can see that currently we have a 0% completion here, and we need to reach it to 100. All right, so the first instruction is very simple. Let me look at the scenario in background. I'm told that in this activity, you'll configure IPv4 and 6 default static and floating static routes. The static route approach that is used in this lab is used to assess your ability to configure different types of static routes only. This approach may not reflect networking best practices. That's correct. So the first thing that we are actually going to do is right here. We're told that we're going to configure IPv4 static and floating static default routes. This PT network requires static routes to provide internet access to internal LANs users through the ISPs. In addition, the ISP routers require static routes to reach the internal LANs. In this part of the activity, you'll configure an IPv4 static default route and a floating default route to add redundancy to the network. That's important for backup. So the first task is this one. Under part 1, we are going to configure on the edge router. That's our first router. We'll configure directly connected. The moment you hear directly connected, you need to think about the exit interface. Directly connected, IPv4 default static route. This primary default route should be through ISP1. Look at that. So from edge router, we need to configure a default route, which is directly connected through ISP1. And so through ISP1, one thing we need to do is to know the IP address. Since it's going through ISP1, we need to know the IP address of this interface here. A tip on how to know that IP address, because we have been given a routing table, we need to go and check which routing table, on the table there, which IP address starts with 10.10.10. Something, okay? Which interface IP or which interface whose IP starts with 10.10.10.0, that is for the edge router. That is going to solve for us the problem. The other way to do that, normally, because no one might give you the routing table, is to always go into the router right here and just say review the routing table, show IP route. So when you say show IP route, and let me just expand this. Look at, and this is very serious here. You're gonna need to be very careful because we have so many addresses that we give this 10.10.10. Something here. But we need to note what is the network address that we are given, 10.0. If you see 10.10.10.0/30, you come and look here. This is our 10.0/30, and this is the IP address of that network. The one that was configured is actually 10.2. So don't be misled here, ladies and gentlemen. It is important using the, in fact, this is the most accurate method of checking your IPs, okay? You come to the routing table. If you see the C will help you to see the network address provided here. But immediately after C, there's always an L, which is here. So the L is actually the IP address we're looking for. But right now, we are not even looking for those ones. Right now, we're just looking for this network here, network address, and what we want is this one, the exit interface, serial 0/0/0. That is the only thing that we are looking for right now. Like I said, the other way would be, I just want to put this on hold here. The other thing will be go to the routing table or to the IP address table and look for this is, of course, our edge router is right here. And this is the IP addresses of the edge router. Okay. So these interfaces, which interface has 10.2? And this is interesting. It is easier to find it within the routing table than to come here, because when you come here, this is 10.10.10.2, 10.10.10.6, 10.10. This another, yeah, they're only these two. So you might be wondering on the edge router, do I take 10.10, which is interface is S000, or do I take S001? So like I said, hey, use the routing table. Go to your routing table and just say show IP route and look at the interface that has the network address you're looking for. We're looking for this network address 10.10.10.0. Look at it here, and we need this interface S000. That's exactly what we need. So on edge router, let's go to the global config, say conft. And the first thing we are supposed to do here is okay. So the thing is, we need to configure this part here. So let me just reduce the size. And let's pick that. So we are told, number one, on edge router configure directly connected static default. So we say IP route, because it is default, static default, we say 0 sorry, 0.0.0.0 space 0.0.0.0 space. Then you need to put the exit interface, which you have seen is S0/0/0. And that's it. That's it. We have 6 marks already. And the next one says, and you can read it with me. Step 2, on the edge router, we need to configure directly connected IPv4 floating static default route. Okay. This default route should be through ISP2 and it should have an AD of 5. Very, very good. So what are we doing? This is what we are doing. This time around, our still on the edge router, we need to configure a floating static default route. So long as it's default, that's okay. But this time around, it's going to pass through ISP2, which is 10.10.10.4. All right. So we need to know which interface is attached to this network here. And because it is directly connected, we need to know that interface. So right here, we look at network 10.4 on this router, edge router, and you can see it's right here. And the interface we are looking for is serial 001, serial 0/0/1. And we go in there very fast and we say IP route 0.0.0.0 space 0.0.0, sorry, 0.0.0.0 space S0/0/1, S0/0/1, and we are good to go. And we need to use an AD of 5 since this is a backup route, as we were told. So we put 5 there. And once we put 5, we should be good to go. We already have now 12 marks here, and we are confidently moving forward. Let's see the next instruction on now part 2. We are on part 2 here. And it says we're going to configure an IPv6 static and floating static default routes. And we'll configure default and floating static default. So step 1, configure an IPv6 static default route. So on the edge router still, configure a next hop static default route. This primary default route should be through ISP1. So the same thing, default route using next hop IPv6 address. And this is where it gets interesting. We know that the command is supposed to be IPv6 route, okay? :/0. That one is constant. Now, since we are being told to use the next hop IP passing through ISP1, this is what we need to do. We know that the edge router passing through ISP1, we need to know the next hop IP because we're doing a next hop static route. What is the next hop IP address? IPv6 address passing through ISP1, and that means we need to get into this router here. Okay, we need to get into this router, the ISP1, and the ISP1. We need to check the routing table, and we need to say show IP route. Now, having checked the routing table like this, we need to see that the network we are looking for is 10.10.10.0, which is here, 10.10.10.0. But we need to know the IP address under that particular network address. It must always be the L following immediately, the L line or the L row following immediately after the C. And that address is actually 10.10.10.1. This is the next hop IP. This is always the IP address of this interface. Now, I don't know whether you can remember. We did say that every time you configure a router interface with an IP address and activate it, that interface will be recorded in the routing table using 2 things. Number 1, the IP address will be recorded with an L, and it will give you the IP address, but the subnet mask will not be the one you have configured. It will be the /32, the total subnet mask. But the router will calculate the network address out of the subnet mask and IP address you have configured, and also record a C here with the network address where that IP belongs, and the network address will be having the correct subnet mask. And so long as you record every IP address, you configure it to an interface, and you activate that interface. Two things get recorded, and you can see that from here. Okay, and you'll always see C and L will always follow each other. Look at another C here, the network address, and its IP address is actually here. So fast forward, we are looking for this IP 10.10.10.1. That is the next hop that we are looking for, configure on the edge router. So we put it here 10.10.10.1. All right. And it's supposed to be an IPv6. Sorry about guys. It's easier to make mistakes here. And let's solve it. So we were supposed to say show IPv6 route, not show IP route. I'm thanking myself for remembering that. So you say show IPv6 route. So if I press enter, I need to see the network address. It is 2001:db8:A:1. And you can see it here, 2008, 201:db8:A:1. :1:/64. This is the one, and the L immediately following it is here. This is the IPv6 address we need. 2001:db8:A:1:1. This is the IPv6 address. This is our next hop IPv6 address we're looking for. And so I can actually copy it, or I will just type it because I know the network address is here. I just need to add a 1 after the double colon without a subnet mask. So I'm gonna just minimize this, bring up my device, and using the IP I have already found, I can just type it here, and it is 2001:db8. It doesn't matter if you put it in small letters because it is case insensitive. 201:db8:A:1:1. All right, and we are good to go. Did we have marks add up? We now have we have 18 marks here. All right, correct. Then the next thing is for part 2, which is configure an IPv6 floating static default route. We have done this already, and now we need to do this. On the edge router still, configure the next hop. See next hop, IPv6 floating static route, and the route will pass via ISP2 and use an AD of 5. Very interesting, but a lot of keenness required. So let's see that. From edge router, we need to pass through ISP2. We need to pass through ISP2, and we need to know that our next hop, because they need a next hop IPv6 route, should be that of ISP2. So, and we'll use an AD of 5. So the first thing to do is to know what is the next hop here. So just a minute. This is okay. So this is the edge router, and they have actually told us that we cannot be able to access that router at the moment. And that means the only other option we have is to go to the table. So let's go to the table. They have locked that router, ISP2. And so we need to go to ISP2 and look at the interface that has this 10.10.10.4. We might only see the IP address there. So ISP2 is right here, if you're with me. Fortunately enough, it is the only interface that has 10.something on ISP2 is 10.10.10.5. This is the IP we need. This is the next hop IP of this interface S001. So we were actually looking for the IP address of this interface, and we can actually be able to see that 10.10. Since the network is IPv4, I need to talk about IPv6. So the network address of this one here is 201:db8 A, colon 2, double colon. So let's go to the routing table here, and the one for A is actually right here. 201 EB8 colon A double colon 2 double colon 1. So I just add double colon 1 at the end of that network there. So on the edge router, I need to say here IPv6 route double colon /0. Then I need to put that IP, and as we can already see it here, it is 2001 colon DB8 colon A colon 2 double colon, and I just add 1 there, and that's it. That is the IPv6 address here, which is our next hop IPv6 address. And we need to add the 5, which is the AD. We need to add 5, which is the AD, to make it floating. And that is that on our edge router. So we have 25 max now, and we are still going on strong. So let's go to part 3, and here is part 3 for you. Configure IPv4 static and floating static routes to the internal LAN. Very interesting. And you're going to configure static and floating static routes from the ISP routers to the internal LANs. So step 1. On ISP1, configure the next hop. Okay. On ISP1, configure next hop IPv4 static route to the LAN 1 network through the edge router. Okay. On ISP1, we need to configure next hop static route to LAN 1 through the edge router. So let's see what that scenario looks like. So here, on ISP1, which is right here, this is ISP1. We need to configure an ISP, a next hop static route to LAN 1. You see the LAN 1 here? This is a remote network for ISP, but it needs to pass through the edge router. So from ISP1, it needs to go through the edge router. It needs to go through the edge router. And so if it goes through the edge router, it means therefore, if this is a next hop, then we need to find the next hop IP of connecting, from ISP to the edge router. And the only way to do that is we could check the routing table and look at the IP address on the side of the edge router. I think we already saw it. It could be here. So since we're talking about 10.10.0, the IP will be 10.10.2. Okay. So this network being shared between ISP1 and the edge router, the interface will actually be 10.10.10.2 on the side of the edge router, and we're gonna need that. So let me minimize this, and I go to the ISP1. And for ISP1, I need us to see something here, because if we don't see this, there's gonna be a problem here. So what I want to do is I want to move this a little bit to this side. Then I'm gonna bring my command line here. And since this is an ISP1, this is a static route. I go to the global config mode and I say IP route. And they're adding the network for LAN 1. You say 192. You can see it there, LAN 1.168.10.16. That is the network address. Subnet mask is /28, and this is going to be 240 at the end. So you must know that 255.255.255.240. All right. And then since this is a next hop static route, we need to put the next hop that we found on the edge router, which was 10.10.10. Sorry, 10.10.2. It was actually .2, and that is very good to go. We press enter, and we now have 31 marks. Then you're told on ISP1 still, we need to configure next hop static route to LAN 2. We need to do the same thing, this time to LAN 2 through the edge router. So remember that we are going to have from ISP1 still going, but this time around to LAN 2, but still passing through the edge router. So we do the same thing. We say IP route and put the network for LAN 2. You can see it's there. It's 192.168.11.32. And the subnet mask is /27. So that's going to be 255.255.255.224. That is /27. And then the next hop will be the same. The one we had put in for the edge router is 10.10.10.2. All right. A lot of keenness, guys, that you must embrace here. So it is the same, the address we found for this interface of the edge router. When you look at 10.0 and the IP, the L was actually 10.2. And if I press enter here, I get 37 max now. We are now operating from 37. All right. Then moving forward swiftly, we are now on step 2. We are now going to configure floats for both those two networks. Okay, we're going to configure floats for those two networks. We're going to configure a float to reach LAN 2. All right. Remember, ISP is reaching LAN 1 and LAN 2 through the edge router. But now we are going to configure ISP1 to reach LAN 1 and 2, this time around through ISP2. Very, very interesting. And so what do? We are going to make that configuration. So step 1 says, step 2 of part A says that on ISP1, configure directly connected floating static route to LAN 1 through ISP2 router and use an AD of 5. All right. So this time around, we're doing a directly connected, which means we use an exit interface on ISP1. So here on ISP1, since this is using the directly connected, we need to know that from ISP1, what is the exit interface? And we can actually see that right here. We just say do show IP route. If you say do show IP route to view the routing table, and I want to see everything here. So what I want to look at is this. We know that this interface of ISP1 contains network 198.0.0.0. So what I'm going to need is which interface is on this network. And we look at here. 198.0.0.0. It is on this. Let me just open this broadly. Look at the interfaces here. G00. 198.0.0/24. You can see an L and a C, but their interface is actually G0/0. That's what we are looking for. That's all that we are looking for. And so what we do, once we know it is G00, we need to configure I need to do this. I need to just put on that here. Or let me put it here. So I need to configure on this ISP1, and I'm going to just say IP route and put the network for this LAN, because this is directly connected. I put the network for LAN 1, which is 192.168.10.16. All right. Subnet mask is 255. Move it a little bit closer here. Yes. The 255.255. Should be 240/28. And then I need to put the exit interface, so it's G0/0. And then I need to put the AD of 5 here. Very important, because this is what is called a floating static route. Okay. So I press enter and I have 43 marks already. And I need to do the same thing for ISP2 passing, no, for LAN 2 passing through ISP2. And we are doing still directly connected. Still you're doing directly connected. So say IP route and put the network here, the network for LAN 2, which is 192.168.11.32. That's the network address. /27 is 255.255.255.224 is the subnet mask of /27. And we just need to put the exit interface, which is G0/0, and you put an AD of 5, and we are good to go. All right. And so having configured that, we now, ladies and gentlemen, up to there, I hope you're going to do it the same way. We have a whole 50%. We have done 50% of this activity. All right. So let's move on swiftly to part 4. All right. And then we go to the last part, which is part 5. So let me just zoom this in so that we see what part 4 has for us. So in part 4, we're going to configure an IPv6 static and floating static routes to the internal LANs. So you're going to configure IPv6 static routes to the LANs. So on ISP1, again, on ISP1, configure next hop IPv6 static routes to LAN 1 network through the edge router. Next hop, which means we need to know what is the next hop IPv6 addresses from ISP through the edge router right here. So from ISP1 here through the edge router, we need to know what is the IPv6 address. What is the next hop? Because they need us to do the next hops. So let's open the edge router, and on the edge router, let's check the routing table here, and we say show IPv6 route. Show IPv6 route and a couple of routes here. But what we are actually looking for is very simple. What we're looking for is very, very simple. We are looking for network 2001 DB8A. So here we go. Network 2001 DB8, not the static routes. We're looking for directly connected right here. 2001 colon DB8 colon A. This is the one you're looking for. Colon A colon 1, because this one is colon A colon 2. So 2001 colon DB8 colon A colon 1. This is the network address. And what are we looking for? We're looking for its IP address, which if this is an L, we're looking for the IP address. This is a C, we're looking for the IP address of an L here, which will be 2001 colon DB8 colon A colon 1 double colon 2. All right. This is the IP that we are looking for. So this is the network address. We're looking for which number is found for this interface. It had been configured 1 double colon 2. That's what we're gonna need as the next hop. And so we get to ISP1 right here. And so on ISP1, on our ISP1, we need to be able to just configure that here. So let's do the IPv6 static route, and we say IPv6 route, IPv6 route. And in this IPv6 route, we are going to configure using the next hop. So we say the network to, look at this, network to LAN 1. The network to LAN 1. Let me just reduce the size of this so that we are actually good to go. All right. So IPv6 route, we need this network of LAN 1, which is 2001 colon DB8 colon 1 colon 10 double colon /64. See that? double colon /64. And then what we need is the next hop IP, which is found was what is up here, but with that at the end. We say 2001 colon DB8 colon A colon 1 double colon 2 colon 1 double colon 2. And that's it. We have 56 marks. And we're going to do the same thing for ISP2. Okay? We're going to do the same thing for, sorry, for LAN 2. And for LAN 2, we do the same thing. You say IPv6 route, IPv6 route, and we say 2001 colon DB8 colon 1 colon 11 double colon /64. Remember, that is the network address of LAN 2 right here. And then put a space, and we need to put the next hop, which is through the edge router, as we were actually told. Next hop, correct. Yeah, still using the next hop. And that next hop is going to be 2001 colon DB8 colon A. Remember, it is up here. It is right here for this network. It is the next hop from ISP reaching LAN 2 through the edge router. So we put this address and we just replace, after the double colon, we put a 2, no /64. So colon A colon 1 double colon 2. Okay. And that should actually sort us out. We are at 62 marks now, just for the avoidance of doubt. And then the next thing we do is we're going to need to go to, we need to go to the second step, step 2 of part 4. Step 2 of part 4. And so step 2 of part 4, we need now to configure a floating, IPv6 floating static routes to the internal LANs. All right. Now on ISP1, we need to configure the next hop IPv6 floating static route to LAN 1 through ISP2. Very interesting. Next hop floating static route to LAN 1, but through ISP2. Let me make it simpler for you guys. So from ISP1, okay, we need to configure the next hop floating static route to LAN 1, the first one. This time round, we need to pass through ISP2, which means, and we're using the next hop, which means we need to go to the routing table, to the IP address table, and check the interface of ISP2, which has 198.0.0 something. So let's go to that table so that we can be able to know what is the next hop from ISP2. From ISP1 to ISP2, the next hop should be this interface of ISP2. So we go to the table and we look at ISP2. So checking at ISP2, the only interface that has 198, it's here. It's 198.0.0.2. That is going to be our address. That's going to be our next hop. So how do you do that again? You look at what is the network address of that link. It's 198.0.0.0/60/24. And I'm making a very serious mistake here. I'm actually supposed to check the IPv6 address. Yeah, it can be very confusing. You need to be very alert to avoid making those mistakes. Remember, we are working with IPv6 and we don't need to look at IPv4. So we need to look at IPv6, and you can see the network address for IPv6 is 2001 colon DB8 colon F colon F. So that's what we're going to be checking for ISP2. So you can see for ISP2, the first one is colon A colon 2. The one we are looking for is 2001.db8.f.f double colon 2. So that is there. That is our next hop. That is our next hop interface of ISP2 from ISP1. So we'll do the same address, but you put a 2 after the double colon. So let's get it going. Only that this time round, we are going to make sure that it has an AD of 5. It has an AD of 5. So still on ISP1, we're going to say here IPv6 route. The network of LAN 1 is 2001. Okay. Colon DB8 colon 1 colon 10 double colon /64. Please, the network address must not have a number between the double colon and /64 because that's the network address. Then you need to put the next hop, which we have already known here. It's right here. We just put a 2 after the double colon. So you say 2001 colon DB8 colon F. Told you, you can use the small letters. It doesn't really matter. Colon F double colon 2. And this time around, we put a 5 here. This time around, we're going to put a 5 as the AD. We're going to put a 5 as the AD. We were at 62 and we're now at 68. We do the same thing. Let's do the same thing. This time around for LAN 2. LAN 2 is right here. So we say IPv6 route. We say 2001 colon DB8 colon 1 colon 11 colon, it's actually not 11, it's 11 double colon /64. That is for LAN 2 network. We need to put the next hop because we're still using the next hop. It's floating, and the next hop, like we did say, you're going to just add 2 at the double after the double colon. So 2001 colon DB8 colon F colon F colon actually double colon 2. Put a space and then put a 5. So that is to show that it is a floating static route to provide a backup. I'm going to need to just press enter to see that we now have how many marks? We now have a whole 75 marks right here. All right. Okay. So once we do that, once we do that, then I want us to now tend towards finishing. Okay, so let's go to part 5 now. Part 5. And we are being given a note here, and it is saying that if your configuration has been completely corrected, you should be able to ping the web server from the host on LAN 1 and LAN 2. In addition, if the primary route link is down, connectivity with the LAN hosts and web server will fail. Let's try that at that point. Let's try to ping the server from the PC on LAN 1. So the server is here. I mean, the PC is here. And I'm going to go right here. Let me check if they have both IPv4 and 6. Yes, they do. So let me ping the server at this point in time. So I'm just going to say ping 198.0.0.10. 198.0.0.10. And let's see if we are going to find some request timeout, and the rest are giving us feedback. All right. Obviously, they were doing an air pre, and I can be able to ping, and it goes that very fast. Let's ping the IPv6. So ping 2001 colon DB8 colon F colon F double colon 10. And you can see we are getting replies even for IPv6. We're getting nice replies over there. It means our static route is working very well. Let me ping from LAN 2. ping the server. It has IPv4 and 6. Well done. And so let me ping these guys here. I'm going to ping the server, both IPv4 and IPv6 addresses of the server. So 198.0.0.10. And what's there? We are receiving replies. That's perfectly well. Ping IPv6 2001 colon DB8 colon F colon F double colon 10. And we are getting replies as usual. Very, very, very good work we are doing here. All right. Anyway, let's finish up our work by going to step 5. Just zoom it. We are at 75. Remember, we just have 25 more points to go, and we will be good to go. So we are told that we're going to configure some host routes here. We're told that users on the corporate network frequently access a server that is owned by an important customer. You see the corporate network here within the LAN here. This is a corporate network. So they need to access a server that is owned by an important customer. And this is the customer server right here. So users on those LANs need to access the customer server. Now, in this part of the activity, we're going to configure static host routes to the server. One route will be a floating one to support the redundant ISP connections. Very good. So what are we doing, guys? On the edge router, we are told in step 1, we need to configure directly connected. On the edge router, we need to configure a directly connected host route with the server. All right. On the edge router, we need to configure a directly connected host route to the customer server. So where is the edge router? Here is the edge router. Here is the edge router. So we're gonna need to configure. We need to configure a directly connected host route to the server here. So let's get to the host server. Before we do the configuration, since we are doing a directly connected, we're gonna need I'm just trying to check through. Okay. Directly connected host route. I'm assuming that directly connected host route to the customer server. Remember, we do not have all information here, and we are told that we need to choose either. Okay, yeah, we need to know whether this route is it the primary route, is it passing through ISP1, and the secondary one is going to pass through ISP2 to reach the customer server here. I'm going to assume so. All right, I'm going to assume so, that the first route will pass through ISP1 and the other one will pass through ISP2. So we're going to see that again when you see Max adding right here. When you see Max adding through here, we are basically going to see that. Now, okay. So let's see how to do that here. So we will assume that the primary path will be through ISP1 and the backup path will go through ISP2. All right. Now, so let's do that. Let's do that right here on our edge router. And let me just go to the global config mode and let me do that. So since we are told that it's going to be directly connected, we need to know which interface of this edge router is this. So the first thing we're going to need to do is we need to check what is the interface of the edge router. What is the interface of the edge router, which has 10.10.10.0. So do show IP route. Since this is for IP version 4, so do show IP route, and we need to see that. All right, so 10.10.10.0 right here. And so since it's directly connected, we're gonna need serial 0/0. That is our exit interface because we're working with directly connected. All right. So let's do that here. And so we say IP route. Remember, we are doing a host route, and you're gonna need to remember that we are actually doing a host route. And so when we do a host route, what we need to do is we need to know the IP address of that particular host right here. So the IP address of that host is 198.0.0.10. 198.0.0.10. The subnet mask that we're going to use is the total subnet mask, which is 255.255.255.255. That is the host route for our address. Once we do that, then since it's directly connected, it's gonna put S0/0/0. That is passing through ISP1. We already saw that. And I'm gonna need to press enter, but I need to see my marks adding up. And there we go. We have just from 75, we're at 81. We were not given all information, but we have used what is called intuition to be able to do that. Then we want to configure the backup for that, the same route, the backup for the same route, which will be passing through ISP2. So we need to know what is the exit passing through 10.10.4. You can actually see that here, that the network on 10.10.4 right here is actually using the interface S001, and that is all that we need. So the same thing, we say here IP route 198, sorry, spelling of route is a problem here. IP route 198.0.0.10. The subnet mask is 255.255.255.255. This time around, we put the exit interface as S0/0, /0/1. We are telling the router, and then we're going to put an AD of 5 without forgetting that, as we were actually told. So we are telling the router, edge router, please always use the link through ISP1 to reach the customer server. If that link isn't available, then you can use the route through ISP2 to reach the customer server. So that's why we put the exit interfaces. The first one is S00 going to S1 and S001 going through ISP2. And so I'm going to press enter here, and I now have 87%. We're moving very well and very steadily, and I'm going to need you to do the same at some point. All right, we are on the very last instruction, ladies and gentlemen, which says that on the edge router, configure an IPv6 next hop static route. Very important. We need to note that. Configure next hop, IPv6 next hop static route to the customer server through ISP1. So this is going to the primary route, primary IPv6 route through ISP1. That information we were not given in step 1, but we have used intuition to get it. Here we are told through ISP1. So we need to know what is the next hop. The next hop from the edge router to ISP1. So the next hop should be the IPv6 address of ISP1. So I'm gonna need to open this IPv6 address, and the routing table is what I need to look at, show IP route. So when I say show IP route, what I want to see is this IPv6 network, which is 2001:DB8A:1. I need to know what is the IP on the side of ISP1. So 2001:DB8A. So here we go. Oh, I did the wrong thing. Must have been IPv6, correct? So 2001:DB8:A. 201:DB8.ff.A1. Yeah, you see these ones are 111, this is 110. We're looking at this one for 1A, and we want to look at the L that follows this C. This is the C. The L that follows it here it means we need to add a 1 at the end of the double colon. So 2001 colon DB8 here, 2001 colon DB8 colon A colon 1 double colon 1. That is exactly what we have found out there. So let's go to the edge router and let's finish this in style. All right. So remember, we are still configuring a host route, IPv6 host route. So you say IPv6 route. We need to put the IP address of the server, which is right here, 2001 colon DB8 colon F double colon 10, and it should be /128, correct? And it should be through the next hop, which is 2001. We saw it for ISP1, DB8 colon A, sorry, colon A colon 1 double colon /64 double colon / no, we don't put any /64 here, by the way. It should be .1 as we had seen. We had actually found it. We had a 1 at the end there. So 2001 colon DB8 colon A colon 1 double colon 1. This should be the second last command we're doing. Then we go. Let's see if marks are going to be adding up here. So I press enter and we are at 93. 7 more marks to go, and then we are good to go. So let's do the floating to that one. So the floating to that is we need to configure a directly connected floating static route through ISP2, are directly connected on the edge router. So we need to know what is the IP address of this particular interface, because we are told it is directly connected. So for our directly connected interface, we need to know this network 10.10.4, on which interface is it on? And we are not even that. It is IPv6, sorry. So you say do show IP. It's very important, very common to make mistakes here. To show IPv6 route. And we are looking for what? What are we looking for? We're looking for 2001 colon DB8 colon A colon 2. We want to look at the interface of edge router. 201 colon DB8 208 colon DB8 colon A colon 2. You can see the C is right here. The C is right here. And you need to know on which interface. Even though the L is also here, both of them will be on the same interface. And you can clearly see that interface is serial 0/0/1 for both the C and the L. So serial 001, because it is directly connected interface. So serial 0/0/1. So you're gonna say IPv6 route, and since this is a host route, we put the IPv6 address 201 colon DB8 colon F double colon 10 /128, and we need to put the exit interface, which is S001 right here. S0, sorry, S0/0/1. And don't forget to put our AD of 5. Without that, it's not gonna work. And when I press enter, I think I made a mistake. I made a mistake, Sam, and it's good that I made a mistake at this point, because my marks are not adding up. We are still doing to the customer server. You say IPv6 route 2001 colon DB8 colon F double colon 10 /128. And because we are using the directly connected passing through ISP2, I think that must have not been the case. I highly think we need to use a next hop. Let me try to see if I can use a next hop, because I'm pretty much sure I'm correct. But without doing that, what I can do is that I could actually go to check results right here. Go to, once you say click check results, you need to click assessment items. Assessment item. And I need to see that this on router 3. Something is incorrect here. On the edge router. Yes. Route 3. And I think that is what might be the problem. So I think our history with this, let me configure here next hop. Let me configure here using the next hop IPv6 address from edge router going through ISP2. Let me see if it's going to be the next hop IPv6 route. I need to know the next hop of ISP2, and that I can get it on the table. And I go to ISP2 and I look at this one, 2001 colon DB8 colon A colon 2 double colon 1. Let me do that here. Okay, so let's put the next hop for ISP2, which is 2001 colon DB8 colon, highly suspect that's the problem, colon A colon 2 double colon 1. I am crossing my fingers that that is actually the problem. And good, perfect, guys. There was a mistake. We have just sorted it out right now, and now we have reached a completion. What happened is that on the instruction here, they have told you to use a directly connected when it is actually wrong. It is actually supposed to be a next hop. So when you do yours, use the next hop here. Okay, do not use the directly connected. This instruction is wrong. And up here, also know what to do right there. So I've actually used the next hop here, the next hop from ISP edge router passing through ISP2. This is the next hop IPv6 address that I've used. So we have reached the end of this class, and this is also the end of module 2. And it's been a journey, worthwhile. And the first thing I would like to do is to give you the assignment. I'd already given you some, but I just have a few more to give to you guys. I already gave you 15.6.1. That is the similar one. It's similar to what we have just done now. Please figure it out and see if you can be able to, to figure out that. Now, from your assignment, yes, I think just 2 more. Just do 1624. It's a syntax checker, 1624, and work on 1631. 1631, 1631, the 1631, and the last one is 1632. 1632, the blue one. 1632, the blue one. Otherwise, I think that's the end of this module. And it's been a journey today, guys. It's been a very, and it's almost getting to 8 o'clock, and we need to actually stop now. Just a few more issues to talk about before we just